All right, let's look at a couple more examples of the extreme value theorem, finding the extrema of a function on a closed interval. So remember, the extreme value theorem says that as long as a function is continuous on a closed interval, it's guaranteed to have a maximum and a minimum, a absolute max and absolute min. Remember, if there's no relative or local, we are talking about absolute or global extrema. So here, we're finding global extrema on the closed interval. So, of course, well, is it continuous? Yes. Is f continuous? F is two trig functions. We know from the first chapter of this class that trig functions, polynomial functions, rational functions, all of our basic, logarithm and exponential, all of those functions are continuous on their domain. So of course the domain of cosine 2x and 2 sine x and their difference, the domain is all real numbers. So this function's continuous for all real numbers, and therefore the extreme value theorem does apply. Okay, so what's our process? Our process is to find the critical values first. So maybe just up here in the top, I'll find the derivative. So f prime is going to be what? Okay, notice that cosine 2x, when we typeset cosine functions or trig functions, and they're just kind of like really basic composite, we don't use parentheses. But notice that is a composite function. So just be careful. Just because you don't see parentheses doesn't mean a function's not composite. There we certainly have, let's see, what's the outside function? The outside function is cosine x, and the inside function is 2x. So we have to apply the chain rule. The chain rule says you take the derivative of the outside function. So let's see, the derivative of the outside, that's negative sine x for the first step of the chain rule. The second step of the chain rule says to evaluate that derivative at the inside function. So evaluate at 2x. So I'll put some parentheses there. And then we multiply by the derivative of the inside function. So we multiply by the derivative of 2x. Of course, the derivative of 2x is 2. Now, I will put that 2 out in front of the sine 2x. In fact, it'll be negative 2 sine 2x, like so. Okay. Oh, you know what? I left off the second part. Sorry. Back up. Okay, that's the derivative of the first function. The second function, we have minus 2 because that 2 is a scalar multiple. And then the derivative of sine is cosine. Sorry about that. I was about to say this derivative is way too short. Okay, now we could say, okay, f prime, and now I'm going to simplify. Derivative of 2x is 2. So I'm going to say negative 2 sine 2x minus 2 cosine x. Okay. Now here's the kind of the problem. If we want to solve a trig functions, okay, I'm ahead of myself. First, what are we trying to do? We need to find the critical values. We need to find the critical value. So we need to find where we need to solve f prime equals 0. So that's negative 2 sine 2x minus 2 cosine x equals 0. Now, here's the problem. When you're trying to solve a trig function, you can't really do this by hand, at least, if you have different arguments. Like here we have a 2x is the argument of the sine function, and x is the argument of the cosine function. You need them either both to be 2x or both to be x. And probably most people would prefer to make them both just an x. And we can do that by using the sine double angle formula. This is a double angle. Now, what's the sine double angle formula? Sine 2x is what? Anybody remember? Trig. This is where your trig identities come in. Occasionally we need to use the Pythagorean, occasionally the sum difference rules. Occasionally the double angles. Now what's the sine double angle? It's 2 sine x times cosine x. Okay, so yeah, that'll allow us to rewrite that sine function without the double angle, just a regular x instead of 2x. So we have -2, and then by substitution, times 2 sine x times cosine x minus 2 cosine x equals 0. Okay. Well, now we have successfully rewritten this so that our arguments are consistent in the trig functions, but now we need to factor this expression so that then we can set two trig factors equal to 0. So notice they both have a -2 in common, so I'll factor out a -2, and they both have a cosine in common. So if we factor out -2 cosine x, we'll be left with a, what's that? That's going to be a +2 sine x plus 1 equals 0, right? We factored out a -2, so that means both terms inside the parentheses will be positive, and we factored out a cosine. Yeah, so that looks like that's correct. Now, to solve this equation, we have two factors, both set equal to 0. We can either say that -2 cosine x equals 0, or 2 sine x plus 1 equals 0. Okay? Now notice this one implies, if we divide both sides by -2, it implies that cosine x equals 0. Now, remember, we're only looking for solutions between 0 and 2 pi. So where's cosine 0 between 0 and 2 pi? Well, I think from our unit circle, that's going to imply that x, oh, not x bar, this isn't stats class. That's going to imply that x equals, okay, at 90 degrees at pi over 2, cosine is 0, and also at 3 pi over 2. That's the two values where cosine is 0, at least between 0 and 2 pi. Now, this next one, if we try to set that equal to 0 and solve, we would subtract 1 from both sides and then divide by 2. So we would get sine x equals -1/2. Okay, so I guess I will draw a unit circle for this. I didn't draw a unit circle for the first. I probably should have, just so I don't really skip stuff. Unit circle, well, more like unit blob. But okay, just to refresh the answers from these first two answers. X is pi over 2 and 3 pi over 2. The reason we know that is because this coordinate right there is 0, 1, and this point right here is 0, -1. Now the x coordinate, that's your cosine coordinate, is 0 on both of them. So that's where the solutions, this first angle right here, that's pi over 2, and this angle right here is 3 pi over 2. Okay, now what about the second equation? Sine is -1/2. Well, where is sine negative? Sine is negative in quadrants 3 and 4. The y values are negative below the x-axis, so in 3 and 4. Now, where is the sine value? Where does it have anything to do with 1/2? Well, 1/2 would be like right here, that negative pi over 6, and right here. But of course, I can't call that first angle negative pi over 6 because negative pi over 6 is not in that interval of interest. I have to call it by its other coterminal radian measure, which is 11 pi over 6. And by the way, the coordinates there are √3 over 2, -1/2. And over here, they're both negative, so -√3 over 2, -1/2. Okay, so this first angle, basically it's pi plus pi over 6, which is 7 pi over 6. So we get two solutions here. X equals 7 pi over 6. And then the other angle, right there, that's 11 pi over 6. You've seen several trig examples now, and I'm quickly going through the calculations to solve unit circle and such. But it's really important that you have your unit circle really known well, because these questions will pop up on homework and tests, exams, and such, where you really got to know your unit circle. Okay, so we have 4 critical values. Looks like. Okay. 4 critical values. Okay. So anyway, I guess I'll condense my list down here. Actually, that's fine. Just leave. Well, okay. Here we go. Crit vals. We have pi over 2, 3 pi over 2, 11 pi over 6, and 7 pi over 6. Not sure why I went out of my order there, but that's all right. So that's step 1, is find critical values. Step 2 is to evaluate the original function at those critical values. So we need f of pi over 2. We need f of 3 pi over 2. We need f of 7 pi over 6. And we need f of 11 pi over 6. Okay, this might take a little bit of work. Let's see what we can come up with. Pi over 2. So we're going to the original function. So I guess I should write all this out. Cosine. Here, let's simplify this slightly. Slightly, though. We plug in pi over 2, but it's 2 times pi over 2. So that gives us cosine pi. Minus 2 times sine of, okay, we're plugging in pi over 2, so just plug it in pi over 2 there. Okay, so cosine of pi is -1. -1 minus 2 times sine of pi over 2. What's sine of pi over 2? That's 1. So you have -1 minus 2 times 1. So -1 minus 2, -3. All right, what about 3 pi over 2? So this is going to be cosine, and we're going back to the original function, f, the original function. Cosine of 2 times 3 pi over 2 gives us cosine of 3 pi. Minus 2 times sine of 3 pi over 2. Okay, cosine of 3 pi, well, that's the same thing as cosine of pi. Those angles are coterminal. So that's -1. So we have -1 minus 2. Sine of 3 pi over 2 is itself -1. So we have -1 minus 2 times -1. So -2 times -1, that's +2. -1 plus 2 gives us, -1 plus 2 gives us 1. Sorry, sometimes it's a lot to juggle in my head. These next ones are going to be harder to juggle in my head. So I might have to write something down for these, or either use my calculator, or maybe just write more stuff down. Are they going to even be nice? Oh, they might not be very nice. So if we plug in a 7 pi over 6, we're going to get cosine. Okay, 7 pi over 6 times 2 would be 7 pi over 3 minus 2 times sine of 7 pi over 6 equals what? Okay, 7 pi over 3, is that that's not an angle that we have on our basic unit circle. Now, is it coterminal to anything? Let's see, 7 pi over 3, 7 over 3 minus 2. Yeah, okay, yeah. It's pi over 3, right? Because, okay, 7 pi over 3. Here, just let me jot down. 7 pi over 3 minus 2 pi, right? Well, 2 pi is the same thing as 7 pi over 3 minus 4. Nope, not 4 pi. Minus 2 times 2, or 3 times, multiply by 3 over 3 would be minus 6 pi over 3, which is pi over 3. Okay, so that is a familiar, undo. That is a familiar angle for us. 7 pi over 3 is coterminal to pi over 3. So what is cosine of pi over 3? Cosine of pi over 3 is 1/2. Okay, so I'm gonna jot this down. 1/2 minus 2. What's sine of 7 pi over 6? Sine of 7 pi over 6. Okay, that's what we were talking about just a few minutes ago here. Over here, sine of 7 pi over 6. 7 pi over 6 is over here. So the sine is negative 1/2. Okay, so the y value is negative 1/2. So we have negative 2 times negative 1/2. So we have 1/2 minus 2 times minus 1/2 would be what? That would be positive 1. So 1 plus 1/2, 1/2 plus 1/2 would be 1/2. So 3 over 2. Now, hopefully I've done that in my head correctly. It would not surprise me if I made a mistake there, but we'll see when we get done here. All right, 11 pi over 6. Okay, so we plug in. It's cosine of 2 times 11 pi over 6. So we multiply this argument by 2. That gives us 11 pi over 3 minus 2 times sine of 11 pi over 6. Okay. Now, just like before with 7 pi over 3, what's 11 pi over 3 coterminal to? If we subtract off 2 pi, that's the same thing as the 11 pi over 3. Now, if we multiply by 3, 2 pi, negative 2 pi, treat it like a fraction. Multiply by 3 over 3, that gives us minus 6 pi over 3. Now, if we subtract, that gives us what? 5 pi over 3, which is a familiar angle, right? Wait, 5 pi over 3? Yeah, 5 pi over 3 is a familiar angle, okay? 5 pi over 3 is, let's get a different color. 5 pi over 3 is down here. Like down there. Okay, and then what are the coordinates there? The coordinates are going to be to that angle. That's going to be 1/2 comma negative root 3 over 2. Okay, so what's the cosine value? Well, the cosine value is positive 1/2. Okay, so that's going to be positive 1/2. Oh, need my black pen back. Positive 1/2. Okay, that was just like before. Positive 1/2 minus 11 pi over 6. That is this right here. What's the cosine? The cosine's 3 pi over 2. No, we want sine, so it's negative 1/2. So we have minus 2 times negative 1/2 is the exact same thing. Okay. So, negative 2 times negative 1/2, that's 1 plus 1/2, I guess, is 3/2 all over again. Okay, all right. We'll check ourselves soon enough to see if that's right. So we have 3/2 for both of those. Okay, so that's step 2 is that took a lot of work. Of course, you could use your calculator to, I suppose, and go a little faster. The only trouble with your calculator is, suppose those solutions had radicals in them. We don't want approximations. Now, I guess when I wrote this problem, I chose the problem to where it worked out nicely. But suppose the answer, the function values had been involve square roots of 2s or something like that. Well, then we would get an approximation if we used a calculator, and we don't want approximations. That's why I was doing them more or less by hand to avoid getting any approximations. Okay, so that is the step 2 of our procedure, which is evaluate the original function at your critical values. Step 3 was just to evaluate the original function at the end points of your interval. So 0 and 2 pi, so f of 0 and f of 2 pi. These should be rather easy calculations. So of course we have cosine of 2 times 0. Well, that's 0. Minus 2 sine of 0. Okay, so what? We have cosine of 0, that's 1, minus 2 times sine of 0. Sine of 0 is 0, so 1 minus 2 times 0, which is 1. Okay? Now 2 pi, we would have cosine 2 times 2 pi would be 4 pi minus 2 sine of 2 pi equals. All right, well, cosine of 4 pi again is 1 because that's coterminal to 2 pi. And then sine of 2 pi is 0, so 2 minus 2 times 0 again gives us a 1. All right, so what do we find? What do we find? Okay, you know, step 4 is just to identify the least and greatest. Since there's so many here, I'm not gonna write them all out again because I guess I'm being lazy. Never mind. I won't be lazy. I like to always do the same steps. I have to fight the urge to be a little lazy. We have what? I'll go in order. F of 0 is 1. We have f of pi over 2. F of pi over 2 is negative 3. F of what goes next? That would be 7 pi over 6 is the next one, I think. Yeah. 7 pi over 6 was 3/2, 1.5. Then we have f of 3 pi over 2 is next in order. That's 1. And we have f of 11, oh, not pi first, 11 pi. And we have f of 11 pi over 6. What do we find that to be? That was 3/2 again. An equal sign would be nice. Equals. And the last one was f of 2 pi. F of 2 pi was 1. So what's the least and what's the greatest? Again, y value. What's the least and greatest y value? Okay, least looks like this guy right here. Greatest looks like 1.5, 3/2. So it looks like the greatest was replicated at 7 pi over 6 and 11 pi over 6. So again, we're always talking about the y values. Extreme values are y values. So what can we say our conclusion is? Our conclusion is the maximum is 3/2 and occurs at x equal, we say 7 pi over 6 and x equal 11 pi over 6. What about the minimum? The minimum is -3 and occurs at x equal pi over 2. All right, let's check ourselves. That was a lot of work, a lot of room for little errors. We have our conclusions. Now let me type out the function and see if it's all correct. So the original function was cosine 2x minus 2 sine x, and the restricted domain was 0 less than equal to x less than equal to 2 pi. 2 pi. And so here we are. Let's see. All right, there we are. That's right. Okay, good so far. We said that the minimum was -3, and that certainly is the minimum. And it happened, it occurred, the location was pi over 2. So that's correct. Good. And we said that the maximum value was 1.5, I believe. And what do we see here? There, that certainly is the maximum, the highest y value, the greatest y value of the graph. It occurs in two places, 7 pi over 6 and 11 pi over 6. So it's always nice to see a correct answer. Sometimes, you know, I'll do this, I'll make a video, I'll get to this part, it'll be wrong, and I'll have to remake the video. But it was right. Okay, it's always nice to see.